So a three-sided figure has 180 degrees. A four-sided figure has 360. A five-sided figure has 540. So we can actually make an equation to represent how many degrees based on how many sides in the figure. Let's see. It's the angle, use capital A, equals 180 times n, where n is the number of sides, minus 2. That way, if you plug in 4 for your sides, 4 minus 2 makes 2. 2 times 180 makes 360. If you plug in 5 in for n, 5 minus 2 makes 3. 3 times 180 makes 540, just like it's supposed to. So this is an equation. You'll see it in some other forms. You might see it like this. And then the angle is 180 n minus 360. There might be different letters, but there's different ways of writing the same equation, right? Okay, so every interior angle in a regular polygon is 140 degrees. So that means if you divide the total number of interior angles by the number of sides, it should equal 140 degrees. Let's see, what can we do with this? I mean, there's an algebra way of doing this. I hope this isn't too complicated, but get a by itself, multiply both sides of this equation by n, and then you have something to plug in for a up here. Okay, so we get 140 n equals 180 n minus 2. And then if you solve that equation, I'm doing it a little fast because there's another way I'm going to show you that this probably makes more sense. 360 divided by 40, that makes 9, a 9-sided figure, which would be a nonagon. Okay, according to that table. And I got this table off Wikipedia too. You could just search, like, if you just search the words pentagon, hexagon, heptagon, should come right up on Wikipedia. The other way of figuring out, we figured out it's a 9-sided figure by making this equation. The total number of interior angles, the sum of the interior angles divided by the number of sides. We were told that equals 140. The other way of doing it is using this equation to come up with how many the sum of the interior angles for each of these. So like the octagon, if we wanted to know what the sum of all the angles was, we could plug in 8 for the number of sides, subtract it by 2, and then multiply it by 180, so that it should have 1080. And now it says, suppose every interior angle in a regular polygon is 140 degrees. That means we should be able to take the total number of angles, divide by the number of sides, and it should make 140. So this one was ruled out because if it's a regular polygon, each angle is the same. So in an octagon, every angle is 135 degrees. And if you wanted to guess heptagon, you could first plug in 7 to find out how many angles, the sum of all the angles inside the heptagon. Whoops. So 7 minus 2 makes 5. 5 times 100. Heptagon had all the angles on the inside of a heptagon make 900 degrees. And then if it's regular, we should be able to split that 900 degrees evenly amongst the 7 angles. So a heptagon has roughly 128. So we know that's not it either. Each angle is 128 in a regular heptagon. So for a nonagon, you could do the same thing. 9 minus 2 makes 7. 7 times 180. The sum of the interior angles for a 9-sided figure is 1260. So if you split that up evenly among the sides, it makes 140 degrees for each side. So that's how we know that's our correct answer. If it's a regular polygon, that means every angle is the same. Like a square is a regular polygon because every angle is 90 degrees. So we can make that list. We said the sum of the interior angles is equal to 180 times n minus 2. So let's write a few down here. Let's do a 6-sided figure, a hexagon. 6 minus 2 makes 4. 4 times 180 makes 720. Let's do a heptagon. 7 minus 2 makes 5. 5 times 180 makes... There's 900 degrees inside a heptagon. You can keep adding by 180. That's probably quicker. Okay, so to find out the angle measurements for a hexagon, each angle is 720 divided by 6 in a regular hexagon. Not all hexagons have to be necessarily regular, but a regular hexagon, all the angles are the same. So every angle in a hexagon is 100, in a regular hexagon is 120 degrees. That's not the one we're looking for. In a heptagon, we got 900 degrees, 7 sides, so if you divide that, makes 128. Oh, that's our winner, right? 900 divided by 7 gives us 128.57 degrees for each angle. So we're dealing with a heptagon, or according to Wikipedia, a septagon also works. I don't know.